Immobilization is the technique used for the physical or chemical fixation of cells, organelle, enzymes or other proteins onto a solid support, to increase their stability and make possible their repeated or continued use. There are 5 methods of immobilization: first adsorption, second entrapment, third microencapsulation, fourth cross-linking, fifth covalent bonding. The first method of immobilization is adsorption. Adsorption is the simplest physical method. Many substances adsorb enzyme on their surface. That's stabilized by the weak bonds, such as hydrogen bonds and van der Waals forces. Examples of supports: cellulose, silica gels, alumina and glass. The advantages of adsorption method are: 1. No reagents required. 2. No cleanup step. 3. Less disruption to the enzymes. The disadvantages are weak attachment, leaching of enzyme, adsorbed biomaterial susceptible to environmental changes, short-term lifetime limited. The second method is entrapment. The definition is: enzyme are entrapped in a support or inside of fibers, either the lattice structure of a material or in polymer membranes. How it works: first mix the biocatalyst such as enzyme in a monomer solution, then polymerization will occur, initiated by change temperature or chemical reaction. Examples of polymer or matrix: first alginate, second carrageenan, third polyacrylamide, fourth cellulose triacetate, fifth agar, sixth gelatin. The advantages of entrapment method are: 1. No chemical modification. 2. Involve in mild conditions. 3. Fast and cheap. 4. Easy to handle. 5. Stable in forms. The disadvantages: inactivation of the enzyme, poor diffusion limitation, small-sized substrate can be used, leakage of enzyme content, low loading capacity.
The third method is microencapsulation. Is a process in which tiny particles or droplets are surrounded by a coating to give small capsules. The process of microencapsulation start with the formation of a miscible droplet of biomaterials by continuous agitation. Then, the deposition of coating will occur by coating material or membrane, such as cellulose acetate, polycarbonate, collagen, polytrifluoroethylene. Lastly, rigidization of coating will complete the process. There are several advantages and disadvantages. The advantages of microencapsulation are: close attachment between biomaterial and transducer. It is very adaptable and does not interfere with enzyme, make it reliable. The disadvantages are: attachment is weak, leaching of enzyme from support. Encapsulated biomaterial very susceptible to environmental changes such as pH. Short-term investigations, lifetime limited. The fourth method is cross-linking. Is an immobilization method uses bifunctional agents to bind the biomaterial to solid supports. Bifunctional agents such as glutaraldehyde, hexamethylene disocyanate and 1,5-dinitro-2,4-difluorobenzene. Is a bifunctional compound. Links covalently to the amine groups of lysine or hydroxylysine in the protein molecules. Immobilization via cross-linking. Achieved by intermolecular cross-linking of the protein, either to other protein molecules or to functional groups on an insoluble support matrix. How its work. Immobilization of enzyme in calginate glutaraldehyde. Enzyme was immersed in glutaraldehyde for half to 1 hour and will aggregate through precipitation and cross-linking with each other. The advantages are: 1. Stabilize the adsorption of biomolecules. 2. Simple and fast method. 3. Cross-linking best used in conjunction with one of the other methods such as adsorption and entrapment. The disadvantages are: 1. Expensive and insufficient result in low enzymatic activity. 2. Change the active structure of enzyme, which will significant loss of activities. 3. Limits diffusion of the substrate. 4. Poor rigidity.
The fifth and also the last method of immobilization is covalent bonding. Definition: covalent bonding is the force of attraction arising due to mutual sharing of electron between the two atoms. Functional groups not essential for catalytic activity of enzyme can be covalently bonded to the support matrix, which is transducer or membrane. This method uses nucleophilic groups for coupling, such as thiol group and imidazole. Nucleophilic groups is a group which act by donating or sharing electrons. Why are lysine residues the most useful groups for covalent bonding of enzymes to insoluble supports? First, due to the widespread surface exposure and high reactivity, especially in slightly alkaline solutions. Second is their rare involvement in the active sites of enzymes. Example of covalent bonding: bicarbonamide. Carboxyl group on support reacted with carbonamide. Reaction carried out under conditions of low temperature, low ionic strength and neutral pH to prevent loss of enzyme activity. Then couples with amine group on biomaterial to form an amide bond between support and the enzyme. The effect of covalent coupling on the expressed activity of an immobilized enzyme. Active site unchanged and ready to accept the substrate molecule, as shown in A and B. Enzyme bound in a non-productive mode in C. D is distortion of the active site. Advantages of covalent bonding are: enzyme or biomaterial will not be released during use. Increased stability of biomaterial. Disadvantages are: reactions need to be performed under mild conditions, more expensive and complex method, support needs to be activated prior to immobilization.